Very good, thanks.
Do you want to write a red line? What's the point?
I think he said as far to the left as I want.
Oh,
Yeah,
good.
that's all right.
Si a mí me llegó también diciendo que mañana no había, pero que se recuperaba el miércoles la lagundiza, que creo que es esta la que no se da el viernes. De hecho, hoy había dos sesiones supuestamente, pero parece ser que solo había una. Me han indicado.
Are we on? It's filming?
Yes.
Okay. All right, welcome back to a tour of topology. So last time I was telling everyone about the most important topological space. I haven't told you exactly what a topological space is. I'm about to. We were talking about what are called open and closed subsets of R, the set of real numbers. So let me remind you, this notation here, A and B surrounded by parentheses, means the set of all real numbers x such that A is less than x and x is less than B. And this is the prototypical example of an open subset of R. This is open. In fact, you can describe all open subsets of R in terms of this prototypical example. So more generally, it works like this. More generally, so we were exploring some properties of open sets. And we learned, for example, that if I have a collection of open sets, a set of open sets, and I take the union of all of those, I get another open set. That was your deceptively simple exercise from last time. So more generally, any union of such things, and these things are called open, of course, open, bounded. We talked about what it means for a subset of R to be bounded above and bounded below. These are open bounded intervals. So more generally, any union of such open bounded intervals is open. In fact, that describes all open subsets of R. So in fact, every open subset of R is of this form. In fact, that would be a perfectly fine definition of open subset of R. The definition I gave you last time involves for every point in the set there exists an epsilon greater than 0 and all that, but we discussed how this is an equivalent way of phrasing it. So here's the notation. So this is the notation for the union of a collection of things. The collection is a union of a collection of sets. Each set I'm writing like this, I alpha, and I take the union over all sets. So alpha ranges over some set A. This is really the only way to come up with some kind of notation for taking the union over a whole bunch of sets. So the important thing here is that each I alpha is an open bounded interval. So you can say is equal to an interval AB for some A and B. It's good to point out that this includes a whole lot of subsets of R. One that you cannot forget shows up every now and then is the empty set. This includes the empty set phi, the set that contains nothing. For example, you could think of this as what you get if set A is empty, then there's really nothing to take the union of. So you get the empty set, or if each of, well, yeah, that works. So what's an example of a closed set? Well, here is, we could call this maybe a prototypical example of a closed set. So